And I felt sorry for the look on your face. My friends, welcome. We begin this next series on something that's called the chain rule. And now the motivation is this, my friends, okay? Take a look at this problem to the left. Determine the derivative dy dx if y is equal to sine of 3x. Now before, we just had sine of x. And when we took the derivative of this, if I said take the derivative of sine, my friends, we get cosine. But what if this is the question, there's a 3x in here? Will this just become cosine of 3x? Or will something happen to the 3x? Well, my friends, this is what we begin to explore what is called as the chain rule. So let's take a look at here. So I might just take a look at a few of these. I won't do all of them, but look at the problem that's parentheses 4x squared. How can we take the derivative of this? Well, we do know the square means that there's two copies. 4x times 4x. So we're going to get 4 times 4 is 16 times x squared. Okay, so now if I want to take the derivative of this, we know it's equivalent to this, so just bring the 2 down and we get 32x to the 1, and that's my derivative function. Similarly, if I want to take the derivative of this to the third, okay, again, I could write 3 of these down, but no need to do so because there's like a invisible ones here, and we know by what's called the power rule, we can just distribute the exponents and multiply 2 times 1, so we get 2 to the third, because we're going to have 3 copies of the 2 multiplying and x to the third. Therefore, we get 8x to the third. Taking the derivative of this, we're going to get 3 times 8, my friends, is 24x squared by subtracting 1. Okay. Now, all we have to do now is figure out some kind of way to try to take the derivative of this in another way that will give me 32x, and we can play around. So for example, let's try doing what we normally do. Well, let's ignore everything on the inside. Well, whenever there's a 2, what do? We bring this down and then we subtract by 1, right? So let's ignore everything on the inside. Let's ignore the 4x, and we know that whenever there's an exponent, we take the derivative, we can bring it down, and we're going to get 2 parentheses 4 times x. Well, what's 2 times 4? Well, we get 8x. Is that 32? No. So this isn't going to work. Well, what can we multiply 8 by to get 32? Well, we can multiply it by 4. Well, do you see a 4 anywhere here? Well, I see a 4 right there. Okay, that's a little bit of a hint. Let's go to this one over here. Okay, 2x parentheses to the third. Bring the 3 down. We get 3. Ignore everything in here. Just ignore like it's not even there. Okay, it was squared. Okay, if we were to distribute this out, okay, just distribute this out, we get 3 times 2 squared times x squared. So we're going to get 3 times 4 times x squared. We get 12x squared. Well, is 12x squared the same thing as 24x squared? It's not. Well, what can I multiply 12 by? Well, I can multiply it by a 2 and I get 24. Well, do you see a 2 anywhere here? My friends, it's right there. So it turns out, just by going through and playing around, that you can take the derivative of a function like this by doing this. Let's have 4x squared. Okay, all you have to do is bring the 2 down first. So you take the derivative of the outside, ignore everything in the parentheses, just like we normally do, like this, right? And now just take the derivative of the inside. Well, what's the derivative of 4x? Well, it's just 4. So you get 4. Well, what's 2 times 4? We get 8 times 4x. And then 8 times 4 is 32x, and that's going to match, and that's all we have to do. Turns out you ignore the inside, take the derivative of the outside, and then work your way in, and that's what we refer to as the chain rule. So if you take a look at this problem here and was to try this out, you take the derivative of this, you bring the 3 down, ignore everything on the inside like that, boom, subtract 1. Now take the derivative of the inside. Well, what's the derivative of 2x? Well, that's multiplying by 2. 3 times 2 is 6. 2x squared, distributing this out here, and we get 6 times 4x squared, which is 24x squared, which is exactly what we get here. And that's literally how the pattern works. So to answer the question up above, well, how do we take the derivative? Well, we ignore the inside, take the derivative of the outside. So dy dx is going to equal derivative of sine is cosine. We leave the inside alone. And now we just take the derivative of the inside. Well, what's the derivative of 3x? Well, we get 3. And therefore, the derivative is just 3 cosine of 3x. Oops, forgot the parenthesis. Boom. There it is, my friends. And that's how it works. So let's just take a look at a few examples and let's make sense of them. So let's look at these here. Okay. Now, why is the chain rule so helpful for a problem like this? Well, if I wanted to take the derivative of this using algebra 2, I'd have to expand this out 5 times because it's raised to the 5th power, and this is going to be really time consuming. And you could do it, but it's really time consuming. But all we have to do really is, well, remember, we're going to do the same rule that we just did above that works. Anytime you have something within itself, okay, well, we ignore everything on the inside here and just take the derivative to the 5th power. So let's write x to the 3rd plus 3 raised to the 5th. So ignore everything on the inside and we take the derivative of this exponent here. So bring the 5 down, we get 5 x to the 3rd plus 3 raised to the 4th power. Multiplied by, well, now take the derivative of what was on the inside. Well, the derivative of x to the 3rd is 3x squared, and the derivative of 3 is 0. Okay, now multiply 5 times 3, we get 15x squared, x to the 3rd plus 3 raised to the 4th power. And there it is. Notice how a problem before using algebra 2 would have took us forever. Now it's only taking us, you know, about a minute, if not less, to be able to take the derivative. So let's try this one over here. Well, so let me just write it down one more time. And you know what? For the sake of it, my friends, let me just take a different color here. Boom, 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 boom. Okay, so now, well, what do? Well, we bring the 3 down, ignore everything on the inside, and we get 3 parentheses negative 3x to the 5th plus 1 squared. Okay, now take the derivative of the inside and we get negative 15 x to the 4th, because I had to multiply this out here with this. Derivative of 1 is gone, boom. 3 times negative 15 is negative 45 x to the 4th, negative 3x to the 5th plus 1 squared. And we get such like this. And that's really all we have to do, my friends. And it's a very efficient way of us to take derivatives instead of having to distribute it all out, okay? So why don't you go ahead and give these 3 and 4 a try. I'm feeling pretty confident where we're at. We're about 7 minutes into the video, and I think we should be good for you to do this. I'm gonna go ahead and go down to these problems down below here. My friends, all right, let's begin to take the derivatives of 5 and 6 over here. Now, notice how here we're dealing with square roots right now, or to the 4th root. So in order to take the derivative of this, my friends, we need to rewrite this. And the way I'm going to rewrite this is, well, there's a 4 out here, and everything on the inside then is going to have to be raised, because it's all underneath that 4th root. It's going to all be raised to the 1/4. Now let's go ahead and take the derivative of this. Bring the 1/4 down, right? We ignore the inside for a moment. 1/4, boom, negative 3x to the 4 minus 2. And then we subtract 1, but we can subtract by 1 in a fancy way as 4 over 4. And we get negative 3 over 2. Okay, well, now we're going to multiply this by, don't forget, the derivative of the inside, which is going to be, derivative of the first term is negative 12x to the 3rd power by subtracting 1. Derivative of negative 2 is gone. All right, let's simplify this. So we were to simplify this. Well, we have to ask ourselves, what's going to go on the numerator? Well, I know the 1 is on the numerator. I know this is multiplying. This is going to be on the numerator. A negative exponent means that we're going to divide. We're taking this and we're going to put it on the denominator. Well, do we already have a denominator in this expression? Well, we do, this right here. So we're going to get a 1 on the top. And it's just a 1, so no need to put it on top. It can be like an invisible one. No need to write it, but we do have this on the numerator on top, so we get negative 12x to the 3rd divided by, well, the 4. Well, the negative here means we're going to put on the denominator, so that entire thing is going to now go on the denominator down over here, which is 3 over 2. And there it is. That would be the simplified expression for a problem like that. Let's go to number 6 here. We get f of x is going to equal, Oops, wrong color. Okay, well, there's no number out here, but remember, square root, it's like an invisible 2. So this whole thing is going to be negative 2x squared plus 1 raised to the 1/2. So if we go to take the derivative of this, boom, 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 we're going to bring the 1/2 down. We get 1/2 negative 2x squared plus 1. Subtract 1 by 2 over 2 to be fancy. This is going to be negative 1/2 multiplied by the derivative of the inside, right, which will be negative 4x. If you work it through. To rewrite this fully, well, what's going to be on the denominator? So let me write a big denominator. Well, the 2 is on the denominator, and this entire thing here, because of the negative exponent, is going to go on the denominator. So negative 2x squared plus 1 raised to the positive 1/2 now that we put it on the denominator. And what's left on top? Well, there's like a 1 up here, but no need to write it because it's just an invisible 1, and we have this negative 4x. Boom. And there it is, my friends. Just a slightly different way for you to think it through. Kind of 2 challenging problems. So you can go ahead and give these 7 and 8 problems a try, and these ones up here, try on the packet and see if it makes a little bit more sense to you. Take care, my friends. We'll begin part 2.